Ooh, look up in the sky. See that white trail? These are called condensation trails or contrails, and they're like artificial clouds planes leave behind. Up there, the atmosphere is of much lower vapor pressure and temperature than the hot gas emitted by the plane's engines. The hot gas and cold air mix together and freeze, turning the gas into tiny droplets of water, and they create the contrails. You can determine the weather by the way the trail looks. If it's thin and short, the weather is nice and the humidity is low. But if the trail is thick and long, it's a sign of high humidity and might be a warning of an upcoming storm. Sometimes contrails can even be colorful. The droplets of water that are formed up in the atmosphere can freeze in different sizes, so they all reflect sunlight at different wavelengths, causing the effect of a rainbow. When all the colors mix, it appears white. That's the color of a common contrail. Meanwhile, there are tiny black triangles above some of the windows on airplanes. The triangles mark the seats that give the best view of the airplane's wings. The crew needs this to find the right spot as fast as possible if they need to inspect the engines, slats, or flaps in case of an emergency. This way, the little triangles save the plane crew a lot of time. An airplane window has 3 panes of plexiglass. That tiny hole you've probably noticed is only in the middle pane. It's there to regulate the huge pressure difference between the inside and the outside of the cabin. Thanks to it, the outer pane can handle the load. If the outer pane breaks, the middle one, even though there's a hole in it, will be able to keep the window intact. That little hole also keeps the windows from fogging up. Airplanes don't take off with the wind, but actually against it. Just think of an airplane as a kite. To make a kite fly, you launch it against the wind, and there it goes. That's because there are 4 forces of flight: lift, weight, thrust, and drag. The lift is generated because the speed of the air is higher above the kite than below it. So the pressure below is higher than the pressure above, and the kite is pushed upwards. This is the lifting force. There's also an opposing force, the force generated by gravity that pulls the object down. That one is called weight. The thrust is the force that pushes the object forward. In the case of a kite, it's generated by the string, the wind, and the forward motion you're making. In the case of an airplane, the thrust force is generated by the engines. Finally, drag is the opposing force of thrust. So, to launch a kite into the air, the lifting force must be greater than the force of weight. Then, to stay in the air, all the 4 forces must stay in balance. Lift must be equal to weight, and thrust must be equal to drag. Now, an airplane needs airflow over its wings to fly. This airflow isn't generated by the plane's engines, but by the wind. The stronger the airflow, the greater the lift. Going against the wind increases the flow of air over the aircraft's wings, giving it some additional lift and letting it get to a higher altitude in less time as it takes off at a greater angle. The same works for landing. Landing against the wind lets a pilot descend faster, covering a smaller distance. The airflow and the lifting force are responsible for turbulence. The direction and speed of the wind and the airflow aren't constant over time. Sometimes they change pretty quickly, like 100 times per second. So one moment there's more lift, and the other moment there's less lift, and the plane is shaking. That's what you call turbulence. It's not dangerous at all, it just means you fly through the area of highly inconsistent wind, and that's all. Turbulence is the worst in the back of an airplane, so if you're afraid of it, try not to sit there. Commercial airplanes fly at an altitude of around 36,000 feet. They travel at that height for extra efficiency. Up there, the air is less thick, so there's less resistance, and a plane can fly faster and burn less fuel. Flying in the lower stratosphere also allows to avoid birds and weather patterns like rain and clouds, as well as turbulence. High altitudes are efficient, but people can't survive out there. So the aircraft are designed in such a way that their shape supports the internal structure. The windows have to be as strong as possible so that they don't crush. Every corner of a window is a weak spot, so a square window means 4 weak spots, and windows that easily break at high altitudes. That's why plane windows are made round. This way, the stress is evenly distributed all over the window surface, and there's less possibility of a window breaking. Most early airplanes were painted metal or chrome colors. Now they're mostly painted white, and there's a reason for that too. Colors absorb light. If you go out dressed in black on a hot day, your clothes will absorb it and you'll feel even hotter. The white color reflects the light, so painting an airplane white means that it will heat up the least possible and will be less likely to be damaged by solar radiation. Also, any other color would start fading over time because it's constantly exposed to sunlight. White airplanes look physically appealing for longer, and white allows spotting any damage on the aircraft more easily. If you've ever taken a night flight, you might have noticed that a plane has flashing lights on its wings. There are different types of those. The red and green ones on the wingtips are called the navigation lights. There's 3 of them. The third one, that's white, is at the end of the plane. From the pilot's perspective, the light on the right side is green and the light on the left is red. They're visible to the pilot with an angle of 110 degrees. The white light at the end of the plane is visible with a centered angle of 140 degrees. So together, they make the whole circle of 360 degrees. These lights help pilots or other planes determine in which direction the plane is flying. If a pilot sees green on the right and red on the left, the planes are going in the same direction. If red is on the right and green is on the left, then the planes are going in opposite directions. But don't worry, even if 2 planes go facing each other, they won't collide. The airspace is 3-dimensional, and planes are assigned to fly at different altitudes. Air traffic is managed by dispatchers who watch for planes and make sure they keep a distance of at least 1,000 feet from each other. There are also flight level regulations. All the westbound flights fly at even-numbered altitudes, for example 34,000 feet or 36,000 feet. All the eastbound flights fly at odd-number altitudes, like 35,000 or 37,000 feet. This means that there are a couple of thousand feet between the planes flying in the same direction. To share the sky safely, each aircraft must follow its own airway that even has a specific name. Aircraft don't have parachutes that can be used in case of an emergency. They only carry oxygen masks, life vests, and boats to use if the plane has to land on water. It seems like parachutes could save many lives, but in reality it's not so. For starters, it's not efficient to have them on board. They're costly and heavy, which means the plane would need to burn more fuel. It would be justified if parachutes could help dramatically, but they can't. Commercial planes aren't designed to jump out of them, especially when there are a couple of hundred people flying. The next thing is that passengers aren't even trained to use them. In case of a real emergency, 200 people trying to deal with a parachute for the first time in their lives would create a real mess and wouldn't help at all. Finally, it's not even safe to jump from those high altitudes planes fly at. So yes, parachuting from a commercial aircraft would be a real drag.